Hey, eighth grade. So today we're going to talk about celestial movement or celestial body movement. This is a review topic from before benchmark 3. So the Earth moves in two major ways. It rotates, which is spinning on its axes. One rotation takes 24 hours to complete. And it also revolves. And the movement of the Earth around the sun is called a revolution. And one revolution takes 365 days or 1 year to complete. There's an imaginary line that passes through the Earth's center and the North and South poles, and this is what we call the Earth's axes. Near the equator, the sunlight directly hits the Earth. So as you notice right here, we have the equator, and you have this direct sunlight coming in between the tropics and the equator area. Near the pole, it arrives at an angle. So the difference between direct and indirect sunlight leads to really drastic temperatures in different places. So, for instance, it's why the poles might be cooler and the tropic would be a warmer area. When you think about the revolution of the Earth around the sun, it takes 365 days, and we have a winter and a summer solstice, and an autumnal and a vernal equinox. And this is just talking about the position of the Earth as it corresponds to the sun on this revolution, on this path that it takes. The moon doesn't actually shine with its own light. Instead, it reflects light from the sun. And the different shapes of the moon you see are called phases. And these are caused by the motion of the moon around the Earth. So as the moon rotates around the Earth, you have phases. So we have this orbit of the moon, and because it only uses sunlight from the Earth, what you see depends on the angle that it then hits the moon. So as you can see here, when the sun can directly hit the entire side that the Earth sees, it's a full moon. And then when the sun's light is blocked by that moon, it's a new moon because the side facing away from the Earth is what's being lit up. When an object in space comes between the sun and another object, it casts a shadow on that object, and we call this an eclipse. The darkest part of the moon's shadow is the umbra, and the largest part of the shadow is called the penumbra. And people in this area only see a partial eclipse instead of a full eclipse. So penumbra, partial eclipse. During a new moon, the moon lies between the Earth and the sun. And a solar eclipse occurs when the moon passes directly between the Earth and the sun, blocking sunlight from the Earth. So the moon's shadow then hits the Earth. So you'll notice that only the area that is in the umbra and the penumbra is the area that has a shadow, and so they're the only ones that actually see a solar eclipse. A lunar eclipse occurs at a full moon when the Earth is directly between the moon and the sun, and the Earth's shadow is the penumbra and the umbra. When the moon is in the Earth's umbra, the total lunar eclipse can be experienced, unlike a solar eclipse. So just by the Earth being here, you'll notice that the entire moon is in the umbra, and then the penumbra is the areas around it. Just another view of the lunar eclipse, where the moon is being eclipsed, and the solar eclipse where the sun is being eclipsed or blocked. Let's do a couple quick review questions. Time it takes for one full rotation of the Earth. Time it takes for one full revolution of the moon. Time it takes for one full revolution of the Earth. When the moon is being blocked by Earth. Phase of the moon during a lunar eclipse. Phase of the moon during a solar eclipse. Outer planets are described as being this. Go ahead and move on to the rest of your packet for today. There's review questions at the end that you should be entering into the exit ticket program.